In architecture school, you're taught to be a visionary. You spend years designing gravity-defying structures, solving spatial puzzles, and dreaming up the cities of tomorrow. Then you graduate, get a job, and spend the next decade staring at a screen, manually matching line weights in AutoCAD. This animated diagram illustrates a typical architect's day, and it reveals a grim reality. Up to 80% of a project's billable hours are consumed by repetitive manual drafting, endless red lines, and moving files between incompatible software. You take someone with a master's degree in spatial logic and structural theory, and you essentially turn them into a high-end data entry clerk. It crushes the creative impulse. The bottleneck is the software pipeline itself. Moving a single idea from a 2D floor plan into a 3D model and then rendering it for a presentation requires constant manual data translation. Every time you switch applications, you lose time and momentum. If every minor tweak to a design requires hours of clicking and updating disconnected files, you stop exploring alternative ideas. The system actively punishes experimentation by burying the designer in clerical friction. For 50 years, computer-aided design and building modeling tools have functioned exactly like very expensive pencils. They only execute the exact coordinates and commands a human manually enters. We are currently seeing a transition toward 2026, where tools no longer wait for manual instructions. Instead, they respond directly to conversational intent. Fixing the industry requires moving past the hunt for faster drafting tools. It demands a shift in how we work, where the software acts as a participant rather than a ledger. This is where agentic AI steps in. Instead of forcing you to manually shepherd files from one program to the next, large language models now act as a central nervous system that orchestrates the entire design pipeline across multiple applications. The AI evaluates site constraints like solar heat gain and wind flow, automatically generating optimized building massing options. As these blocks resolve into wireframes, the system runs automated code checks, flagging structural conflicts and updating schedules directly inside the model. Historically, a team of junior architects would spend weeks pulling environmental data, building initial massing, and cross-referencing zoning laws. An agentic system executes the exact same analysis in a few seconds. By offloading that heavy analytical lifting, the massive technical hurdles that used to stall the earliest phases of a project completely disappear. Zooming in from the city grid down to a single room reveals exactly how a designer guides this process. When people first use these tools, they ask for a cozy room. They treat AI like a decorator and get back useless, generic pictures that completely ignore the actual physical space. This split screen demonstrates the correct approach. A professional prompt requires strict constraints. You have to dictate context, specify exact geometry like ceiling heights and load-bearing walls, and define material limitations. Even with a perfect prompt, the first output is rarely the final answer. It is a rapid prototype. You have to analyze what the system produced, identify the spatial flaws, and feed specific adjustments back into the prompt to refine the layout. You cannot write these constraints or evaluate the output if you don't actually know how buildings work. You still need a deep, rigorous understanding of proportion, structural logic, and material behavior to guide the machine. When you stop manually drawing every line, you have to clearly articulate your exact spatial intent. Mastering this loop turns a passive drafter into an active, critical director of the design. If a system can lay out a floor plan, verify the building code, and render the final presentation while you grab a coffee, what exactly is the human architect supposed to do? The machine has a massive blind spot: context. It can optimize a grid, but it does not understand the historical weight of a specific neighborhood or the unique topography of a physical site. It has no ability to walk down a street and feel how a community actually lives, or understand the emotional impact a building's shadow might have on a public park. Urban planning requires navigating brutal, nuanced trade-offs between affordable housing density, sustainable material sourcing, and local economic impact. Algorithms cannot weigh human ethics. And legally, a line of code cannot hold a professional license. It cannot assume the liability for a collapsed roof, and it cannot swear an oath to protect the health, safety, and welfare of the public. Architecture requires synthesizing legal requirements, cultural history, and emotional resonance. Those variables don't exist in a training dataset, which is why the core responsibility of design rests entirely with humans. Automating the hours spent fixing door schedules and matching window heights restores the profession to its visionary core. Imagine a studio where all of that highly educated brainpower is finally diverted away from manual data entry and focused entirely on solving the housing crisis, adapting to climate change, and building healthier communities. Delegating repetitive labor to an algorithm allows the designer to focus on the high-level decisions that define the human experience of space.